osmotic pressure, the last colligative property, the fourth colligative property. And now I would like to give you another question on this, and then we will move to another topic. Just wait a minute. I'm going to give you a question. Yeah, where is that? Here it is. Okay, so the question is, you can see 5% weight by volume sugar solution is isotonic with the urea solution. Urea solution if molar mass of sugar is 342. Calculate the molar mass of urea. Now, if you will not be able to solve it, just let me know. Yeah. See, Austin, it's very easy if you know what does this isotonic means. Do you know what does this isotonic means? This isotonic actually means that both have same osmotic pressure. Both have same osmotic pressure. As you can see that there are two solutions. The one with sugar solution and another is your urea solution. So let's say this is your osmotic pressure of sugar and this is your osmotic pressure of urea, and in the question it has been given that they are isotonic with each other. That means their osmotic pressure are equal. Now as you can see that we are going to apply the formula, since you know that this osmotic pressure is equal to MRT, molarity into constant into temperature. This is the formula for osmotic pressure. So if I am going to apply this formula in osmotic pressure of sugar, it will be molar mass of sugar into R is constant and temperature is also constant. So R and T will be as it is. Again, molarity of urea into R into T. Is that clear?
Yes.
Okay. Now see, since R and R is common in both, so we can easily cancel this with each other. RT and RT will be cancelled. Now molarity has a formula, that is number of moles of solute upon volume of solution in liter. And here you can see number of moles of solute upon volume of solution in liter. Volume of solution in liter. So what you need to do, it's very simple. Just let me see the question. Yeah. Okay. I forgot to write one more thing in the question. That's why I was looking at the question. With the urea solution, isotonic with this I forgot to write 0.87% weight by volume urea solution. This is the complete question. I forgot to write. Sorry. So the question is 5% weight by volume sugar solution is isotonic with 0.87% weight by volume urea solution. If molar mass of the sugar is given 342, we need to calculate the molar mass of urea. Now, what does this isotonic means? Isotonic means both have same here osmotic pressure. So as you can see, when you are going to expand this in the previous class or in the first class, I explained that this means 5 gram of sugar or solute in 100 ml of solution, in 100 ml of solution. So from here you can see the volume of solution is basically 100 ml. And if you are going to expand this, if you are going to expand this, that means 0.87, just wait a minute, let me change this, 0.87 gram of urea of solution, 100 ml of solution. So you can easily see that both have same equal volume. So if volume is equal, so volume will also be cancelled. Now you have only left number of moles of solute of both. So what I'm going to do, it's very simple. I'm just going to write number of moles of solute, and that will be equal to number of moles of, sorry, not solute. This is your sugar of, this was your sugar and this was your what, urea. So this will also be written as solute here is your sugar and the solute here in this solution is your urea. This is a formula given mass upon molar mass, and this has also a formula given mass upon molar mass. So I'm just going to directly apply the formula. Given mass of sugar is 5 and molar mass given 42. Given mass is given 0.87 and molar mass is, we need to calculate. Now you can easily calculate the molar mass from here, right?
Yes.
Please do calculate it and let me know. Austin, have you got it?
Yes, sir. Sir, could you show the question, please?
Yeah, this was your question. Now, are you done with this?
Yes, sir.
Okay. Everyone done with this?
Yes,
Now,
sir.
moving to the next topic, that is your azeotropic mixture. So it's very easy and very, very important. So I'm gonna write here azeotropic mixture. You can see what is azeotropic mixture. So basically, first of all, I'm going to just not define it. I'm going to give you the conditions which will be fulfilled and you will be getting azeotropic mixture. So the first is basically binary solution. Azeotropic mixture. The first condition for this is your binary solution. That means there will be only two component. One is solute, another is solvent. Simple. Both should be in liquid state. The second condition is fixed composition. Fixed composition. That means basically to make an azeotropic mixture, it is not that you are going to mix in any proportion the solute and solvent and you will get azeotropic mixture. There is a fixed proportion or fixed composition and you will be getting azeotropic mixture. Now the third is basically constant boiling point. Constant boiling point. After mixing them in a fixed composition, after mixing a binary solution in a fixed composition and getting a azeotropic mixture, and you know what will happen, the boiling point of the component that is present in the solution will be equal. As you know that if you are going to mix two liquid together, just let's say this is a scenario and there is A and B both in the solution, and if this has a 100 degree centigrade boiling point and if this has 50 degree centigrade boiling point. But in azeotropic mixture, what happens when you are going to mix them, the boiling point will be constant for both, and hence due to which fractional distillation is not possible. Fractional distillation is not possible. Are you aware of this distillation and fractional distillation? Yes or no?
Yes, sir.
It is like if you're if basically when there are more than one component present in a container, and if you want to separate or if you want to take one out from there, you are going to heat it at lower boiling point, like 50 degrees centigrade. I'm going to heat it. So what will happen, and there will be like this, and this will be connected with another container which will be cooled. So at 50 degrees centigrade, this B will convert into vapor, will be converted into vapor and travels, and here comes, and since cooling is here, so it will again convert itself into liquid state. And in this container, you will be left with only A. And now if you want A, pure A, you can get it from the black. And if you want pure B, you can get it from the orange one. Are you getting my point? This is the fractional distillation. But what happens in azeotropic mixture, when you are going to mix them in a fixed composition, when you are going to mix a binary solution in a fixed composition, and if you get a azeotropic mixture, the boiling point will be same for both, and it is not possible to separate with the help of this fractional distillation, because both will have same boiling point. If you want to boil it or convert it into vapor, both will be converted into vapor together and both will travel in this container, another container. Are you getting my point, both of you?
Yes, sir.
Also, now The most important part here is that let's take an example. You know that this C2H5OH, this C2H5OH, and there is H2O. When you are going to mix ethanol into water in any proportion, it is not necessary that you will be getting azeotropic mixture. But if you are going to mix this in 95% weight by volume, or weight by volume, you can say weight by volume, or weight by weight you can take. So you will be getting this azeotropic mixture. What I want to say is that 95% this part and 5% this part. So you will be getting this azeotropic mixture. Now there is a question, why their boiling points become constant? So it's very simple. What happens when the boiling points of the components will be equal? So when mole fraction will be equal to mole fraction of water, both are mole fraction. Y is also here representing the mole fraction, but this is in liquid phase and this is in vapor phase. In the same way, this happens, mole fraction of ethanol in liquid phase will be equal to the mole fraction of ethanol in vapor phase. So basically, when you are going to mix in a fixed composition, their mole fraction in liquid phase and their mole fraction in gaseous phase or vapor phase becomes equal, and hence their boiling point becomes constant, and due to which fractional distillation is not possible. And you also know that this is a solution which is non-ideal solution, positively deviated, non-ideal solution, and which is positively deviated. Please do write it. Everyone done with this?
Yes, sir.
Now see what will happen here. Azeotrops. This is your azeotrops. And this is minimum boiling point, and this is your maximum boiling point. See what happens here, it's very easy. Minimum boiling point, basically the solution which shows positive deviation, will have minimum boiling point, and the solution which shows negative deviation will show maximum boiling point. Why? So as you know that in a positive deviation, in positive deviation, basically the graph was like this. This was the graph for ideal solution, but for positive deviation, the graph was like this. Yes or no? This was like this. Are you getting my point, both of you?
Yes,
Please
sir.
do respond. This represents basically when you are going to mix it and you are getting a positive deviation. So basically, you can see the vapor pressure is increasing. The vapor pressure is increasing, and that represents basically its boiling point decreases. Why? As you know that vapor pressure increases, that means force of attraction decreases, and hence the boiling point will be decreasing. That's why positive deviation in a geotropic mixture, you can also say minimum boiling point, because when you are going to mix two solution, sorry, a solute and a solvent, and if it shows positive deviation, that means the force of attraction between the particles decreases, and hence the boiling point will increase. Let's say there is a water and there is C2H5OH. Let's say this has, you know, that 100 degrees centigrade is the boiling point, and boiling point of the ethanol is basically around 60 degree, around this much. Okay, so if you are going to mix them, they show positive deviation. Positive deviation, that means vapor pressure increases and hence force of attraction decreases. Now the boiling point of the solution, when you are when you mixed it, will you know what will happen? The boiling point of solution will decrease lesser than at this also, both lesser than both. And as you know, this is your 100 degree centigrade, this is your 60 degree centigrade, so it decreases lesser than both. Are you getting my point?
Yes.
Yes, sir.
Now you know what, when you are going to mix HNO3 in water, you will be getting negative deviation. Negative deviation, that means basically vapor pressure decreases. Why vapor pressure decreases? When you are going to mix them, the force of attraction increases, and when force of attraction between the particles increases, you require more energy to convert that particles into vapor, and hence the boiling point increases. Now the boiling point increases more than uh, two of them. Are you getting my point? In the way you can see, this is your 100 and this is your 60, and it decreases below this, the lower value. In the same way, it increases increases from both of them. Okay, so this is the concept for minimum boiling point and maximum boiling point. Are you getting my point?
Yes.
Okay, so you can do this if you want. Just draw a graph with me. The graph will be similar like this, and I'm going to draw a graph here. Just wait a minute. Here it is, like this. Now you know that this will be like this, and this will be like this, and you also know that this is a graph for ideal solution. Okay, so this is your vapor pressure and this is your composition mole fraction. Now you know that zeta is equal to 1. I had written zeta b is equal to 0, and again zeta b is equal to 1, and then again zeta a is equal to 0. Now what will happen? You can see the graph for positive deviation will be like this. The graph for positive deviation will be like this. Okay, this is the pressure of the solution. Your P total you can write if you want. Okay, in the same way, I'm going to draw this as well. This is your this is the graph for positive ideal solution. But if you want to draw for negative deviation, wait a minute. No, you know that this will be your P naught A. That's on understood. P naught B. I forgot to write in the previous graph as well. P naught B, and here it is P naught A. Now, what will happen? Since it is negative deviation, the graph, there will be decrement in vapor pressure, and hence it will be like this. And this is your PT, or pressure of the solution. Simple. So as you can see, it is decreasing, right? Just write it, and corresponding to this, I'm going to draw a graph for boiling point as well, the negative boiling minimum boiling point as well as the maximum boiling point. Are you done with this?
Done, sir.
Okay, now see. Just wait a minute. Now see, there is a graph, as you know. I plotted a graph for temperature versus uh, temperature versus mole fraction, or you can say composition. The graph will be like this or this. So let me just show you. I'm just going to plot a graph for minimum and maximum boiling point. So the graph will look like same. Just wait a minute. Now see, this is a graph between temperature and mole fraction. Okay, so this is a graph between temperature and mole fraction, and this is again zeta is equal to 1 and zeta b is equal to 0. Again here zeta b is equal to 0, sorry 1. Zeta b is equal to 1 and zeta a is equal to 0. Now see what will happen. A is pure here. And let's say the boiling point of A is lower than the boiling point of B. That means basically, just wait a minute. What I have plotted here, that depends. Okay. So can you tell me if P naught A is here and P naught B is here, that represents basically A is more volatile than B? Yes or no? A is more volatile than B. Are you getting my point?
Yes,
Because
sir.
A has more vapor. Okay, that's why. Now, as I told you, when you are going to mix them, their boiling point becomes equal. So it will be like this. Since this is your positive deviation, more vapor pressure, less. Uh, Wait a minute, I just need to check. Yeah, more vapor pressure. That means less boiling point or minimum boiling point. So we are going to draw this graph as this. Just wait a minute. I need to go from here. Please wait. I'm not able to draw the perfect graph. Yeah, now it will be. Not again. Please wait. I just want to draw perfect. The last try. I'm gonna give you the last. can hold on a minute. Okay. So you can see this is the boiling point of A and this is the boiling point of B. Boiling point of B. Now this will be the boiling point of shit. Wait a minute, please. This is the boiling point of the solution. What I did here is very, very wrong. Just wait a minute. Okay, yeah. So as you can see, in negative deviation, maximum boiling point. What does this means? You can see separately it has this boiling point and it has this boiling point. But when you are going to mix them, it shows negative deviation. That means vapor pressure decreases and boiling point increases. And hence boiling point increases. That means you can see the solution's boiling point is quite high. Now I'm going to draw for positive deviation or minimum boiling point. So again, this will be your zeta is equal to 1, zeta b is equal to 0. And again, zeta b is equal to 1 and zeta a is equal to 0. Now you know that this will go like this. It's boiling point. The boiling point of A is here and the boiling point of B, you can see, is here. Boiling point of B is here. But when you are going to mix them, its boiling point is this. So boiling point of the solution decreases. That's why in positive deviation, minimum boiling point, minimum boiling point, and negative deviation, maximum boiling point. Are you getting my point?
Yes. Yes.
Please do write it. So both of you have both of you have exemplar book.
You mean textbook?
Yeah, the exemplar in which MCQs and varieties of questions are there, which is very important for you. Let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. So I was asking about exemplar. Do you have exemplar? Yes or no?
I have the textbook, not any other different.
Yeah, textbook. Inside that textbook, it is full of question, right? Or the theory part.
Theory and
Theory is there. Okay.
questions. Few questions are.
Few questions are there. No. Both of you have maths, right?
Yes, sir.
No problem. Just wait a minute. I'm going to give you some hints for. Okay, there are some questions that has been asked. If I'm going to ask you a very simple question that CH3OH plus H2O, Will you be able to tell me whether this is a ideal solution and non-ideal solution? Just answer me straight. Will you be able to tell me whether this is ideal or non-ideal solution? What do you think? Will you able to answer me or not? Austin, yes or no? Hamam?
No, sir.
Okay, see, yeah, if you don't know the trick, you cannot tell actually. And if you know the trick, you can easily tell me. Problem is that it's two way to check it. The first one is experiment. How you are going to do it? You know that this will have 100 degrees centigrade, and this will have boiling point, which is around 50 or 60, 50 degrees centigrade. Let's say 50 degrees centigrade. Now, when you are going to mix them, and then again you are going to check the boiling point by keeping them together in a container and boil it, and just check the boiling point. If the boiling point it's same, if the boiling point you can see, if the boiling point is lower, then it will be positive deviation. If the boiling point is uh, greater, then it is negative deviation, because in positive deviation the boiling point decreases, as you have seen, and in negative deviation the boiling point will increase, as you just have seen. Now I'm gonna make a list, and it will be very useful for you. Please do write with me. This is your ideal solution. On this side, I'm gonna give you a whole trick, and this is your non-ideal solution. Non-ideal solution will be divided into two parts. I'm telling you already. So before writing it, just look how I'm gonna write it. This is your non-ideal solution part. Now, what I'm going to do, it's very simple. So this is it. Again, if I'm going to do, I'll just wait. Okay. And this part again will be divided into two parts. Positive deviation and negative deviation. And here it will be negative deviation. Now, which solution will show positive deviation and which solution will show negative deviation? It's very simple. First of all, when you are having a solution when you are having a binary solution, and both the components are similar, that means it is ideal solution. Are you getting my point? Similar, like what? If I'm gonna tell you that this is the mixture or the solution of n-butyl chloride plus n-butyl bromide. So are you you can see that butyl, that means hydrocarbon having 4 carbon, and this is your chloride and bromide, that means halogen are both are halogen, so they are similar to each other. Yes or no? Austin and Humamuddin. So whenever you are going to mix, whenever you are getting a binary solution of similar nature, or if they are similar, they will be ideal solution. They will be ideal solution. Like if I'm going to ask you this, if I'm going to ask you ethyl bromide or ethyl iodide, you can see they are similar. Yes or no? So again, that's why I put it on ideal solution side. The third we can go for, you know that chlorobenzene. Chlorine is halogen, and benzene, you know, and bromobenzene. Again, they are similar. So it is again ideal solution. The fourth you can see hexane and heptane. Basically, alkane they mix and got an ideal solution. Is that clear, both of you?
Yes, sir.
Now, the next most important point is that how you are going to decide whether it is ideal or non-ideal solution. So it's very simple. How it is very simple. So as you know that, as you know that, if ideal solution is about similarity, so non-ideal solution will be about dissimilarity, right? Yes or no?
Yes, sir.
So how we are going to, it's very simple as you can see. As I told you, similarity that is ideal solution, dissimilarity that is non-ideal solution. But how you are going to get positively deviated non-ideal solution or negatively deviated non-ideal solution? So there is a very simple trick. The trick will be failed. There will be some exception, but very little. So you can remember that. Always remember that the solution in which alcohol is present, mostly that will be your positively deviated non-ideal solution. So the trick is simple. For ideal solution, similarity. Okay. And for non-ideal solution, dissimilarity. Dissimilarity. You can go for this. For non-ideal solution, I'm writing for this non-ideal solution. But for positive deviation, alcohol. And for negative deviation, acid. For negative deviation, acid. Are you getting my point? Like if I have written here CH3, just wait a minute, it's a little bit hanging. CH3OH plus H2O. Now you can see alcohol is there. I asked you this question. So if alcohol is there, that means it is non-ideal solution with a positive deviation. Both are different, simple. Now again, methanol, this is your ethanol. Again, this is your ethanol, that is alcohol plus water. Are you getting my point, both of you?
Yes, sir.
Yes, sir.
Just wait a minute. Sometimes it doesn't. Oh, okay. Again, the next one, we can go for CH3OH, that is your methanol, and CCl4. Again, you can see this is your alcohol. Again, the next is ethanol. You can write the formula as well, and cyclohexane. Cyclohexane, you know, both are different, and also both are one of the component is alcohol. The next one, which is not alcohol, you can see acetone, that is your propanone and carbon disulfide. I will mark it a star. And then comes your acetone again. Acetone is your propanone, functional group ketone, and ethanol is also there. So ethanol in this is present. Now the next, as I told you, is acid. So there is HCl plus water. You can see acid is there. HNO3 plus water. Water plus methanoic acid. This is also acid, methanoic acid, carboxylic acid. You can go for water plus ethanoic acid, CH3COOH. Now the next, which is not an acid, you can say CHCl3 chloroform plus benzene. Chloroform plus benzene. You just don't need to remember all. I will give you the shortest path you can do for pyridine. Now, this one is alcohol as well as acid. And in this carboxylic acid is senior, so you can remember it like that. Then again, acetone, that is your propanone, CH3COCH3 plus aniline. So first you are going to write it, and then I will explain. It is simple.
Are you Austin, am I audible? Austin.
Yes. Yes.
Oh, am I audible to all of you?
Yes, sir.
Uh, am I audible? Can you repeat, please? Please.
Yes, sir.
Okay. So let me know when you are done with this. Thank you. Thank you, Austin. This is your CSC. In the next class, that means on Thursday, we will be completing this chapter. We will finish this chapter.
Yeah, done, sir.
Can you see the screen? Austin, can you see the screen and Humamuddin?
Yes, sir.
Okay. So basically, I already told you what is ideal solution. Similar components will be present in a solution that will be your ideal solution. For component will be there. Now, if alcohol will be there, that is most probably it will be your positive deviation. Positively, you can see alcohol, 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 and alcohol. This is also alcohol, but this you need to remember. When they mix together, the force of attraction decreases and hence they show positive deviation. This you can just wait a minute. Yes, everyone, Austin, sorry. So you can see this will be exception or you can remember this. And this next question, acetone plus ethanol. Alcohol is there, so it's very simple. Now for non-ideal solutions showing negative deviation is your acid. This is chloroform and benzene. When they combine together, the force of attraction increases and hence it shows negative deviation. Again, this is your acid. Again, this is your acid and alcohol. So you can remember it like this. The carboxylic acid is senior most functional group. So the alcohol will follow that. So it will show negative deviation. And again, you just need to remember this. It's very simple, isn't it? So I think you can do this type of question. They will be asking question like this. Also remember, they can ask question in terms of maximum and minimum boiling point of azeotropic mixture. As I told you, minimum boiling point, that means positive deviation. They are asking you for for positively deviation, and maximum boiling point, that means negative deviation. Are you getting my point, both of you?
Yes.
Yes, sir.
Okay, so this question I'm going to give you. Please think about it and answer me correctly, please. Oh, very good, Austin. Hama, what about you?
Negative deviation will show that the maximum
Tell me the.
value.
Okay.
Water and
Uh,
nitric acid, I think.
what is the option? You should tell me. Yeah, very good. So the option is A. Both of you are correct. The mixture that forms maximum boiling point, that means negative deviation. It is non-ideal solution with negative deviation, that means the acid part. So you can see water plus nitric acid, ethanol plus water, positive deviation, acetone plus carbon disulfide. Whenever you are going to get this type of option, you are going to revise with the option as well, so that it will be remembered for long time. Okay, acetone plus carbon disulfide, this is also your positive deviation. Heptane plus octane, that is your ideal solution. Okay, please. So basically, it's very easy to decide. So what I was telling you, that when you are getting this type of option, you are going to see for other options. If you know the answer, first you need to solve the question and then also think about other options. It will clear your lots of doubts. Okay, just wait a minute, please. Okay, now the question, this is your. This is your question. Very easy. Oh, very good, Austin. Any answer, Mom? Positive deviation. You can look on in the option as well. See, benzene toluene, this is your ideal solution because both are same. Chloroethane, bromoethane, this is also ideal solution. Now, acetone plus chloroform. Acetone plus chloroform. If you will look in negative deviation, is there any acetone plus chloroform is there? No, not there. So always remember that, put this in negative deviation. Please do write it in your the list that I have given. This is your negative deviation. Maximum boiling point it will have. And this, if you don't, so this is your positive deviation. So option is D.
Is that clear, both of you?
Yes.
Okay. Yeah, so this is it for today. Wait for ma'am. She will be coming and taking your test. Okay. So I'll see you in the next class. Okay. Thank you, everyone. Am I audible?
Yes, sir.
Okay. Thank you.
Thank you, sir.
Thank you.